here we actually need to solve question number 4, which is part of our practice material. This question number 4 is given the following system of three equations, and we need to find the values of x, y, and z by matrix inversion, and second is through Cramer's rule. So these are three simultaneous equations, and we can solve them using these two different methods. So first we actually will solve using the matrix inversion. So let's find first the equations in matrix form. So these equations in the matrix form, first we write the matrix of the coefficient. From the first equation, the coefficient of x is 1, the coefficient of y is plus 1, and of z it is negative 2. Similarly, from second equation we got 2, negative 1, negative 3, and from third equation we got negative 1, negative 2, positive 4. And now the next matrix is of variables, and we have x, y, and z. That actually equal to our the matrix of our constant values, which are negative 1.2 from equation 1, and from equation 2 it is 3.6, and then we have 15.8. So this equation of matrix, we can write it as that the matrix of coefficients is A and variables is x, that is equal to C. Okay, so now what we can do, we actually need to find this matrix x. So according to identities of matrix, what we can do, we actually apply the inverse of A both sides. That is going to be like this. Now we know that the inverse of A times the inverse is equal to identity matrix, and if you multiply this identity matrix with any matrix, that will not be changed and answer will be the same. And this is just like one multiplication a number, and we get just a number, but then again the order should be actually according to the multiplication order, meaning that the multiplication is allowed there. So now we got x is equal to A inverse times C. Now what we need to do, we need to find A inverse. So A inverse is actually equal to, we know that it is a adjoint of A divided by the determinant of A. Determinant of A. Okay, so now what we can do, we can find first of all determinant of A. What the determinant of A is, that is actually A and these two straight lines, that means the determinant. And now in the same way, here we have a determinant of 1, 1, negative 2, 2, negative 1, negative 3, and negative 1, negative 2, 4. So the method of finding determinant is that you can select any row or any column. What I do, I select the first row here, the first element of the first row and first column is 1, and it will multiply with the determinant of the rest of the elements, meaning the minor. Minor means that you are leaving your first row and the first column, and you left with -1, -3, -2 and 4. Now the next element is actually 1, and this one will go with negative because the rule is that we do have multiplication of -1 I plus j. So here I is the number of row and j is the number of the column. So here we have this second element of first row and the second column, meaning that 1 plus 2 is 3 and -1 power 3 is negative. So here we will have a negative sign times this element which is over here 1, and then we left with the minor of 2 -3, 2 -3, -1 and 4. So next element is -2, but here we will have the positive, but this negative is because of the -2, and now we are leaving again first row and the third column. So we lift with the minor of 2 -1 -1 -2. Now what we can do, we can find their you can say the determinants. So the rule is that we are going to multiply these diagonal elements. It is 1 times 4 times -1 is -4, and we are going to take away our multiplication of the second diagonal elements, -3 and -2. It is +6, and this negative because of the formula, so -6. Now we have a -1 times 4 times 2 is 8, -3 times -1 is +3, but it will be -3 because of the rule, and again -2 times -2 times 2 is -4, and then -1 times -1 is +1 and -1 because of the rule. Now here -6 -4 is -10, and 8 -5 is 8 -3 is +5. First 5 times -1 is -5. Now -4 and -1 is -5 times -2 is +10, and now this answer is +10, -10 gone, and we left with -5, and this is the determinant of A. So now what we can find here, that this is the determinant. Now we need to find the adjacent of the A. Before that, we can actually mention this determinant of as delta naught, that we will use later. Particularly it will be useful for the Cramer's rule. So we are using actually the matrix rule so far. So now we need to find the adjoint. To find the adjoint, what we need to find, first we need to find the cofactors of A. Just actually for our you can say the keeping this matrix A in front of us, I am writing it again over here. So 1 1 -2 and 2 -1 -3 -1 -2 and 4. So here we need to find the cofactors, sorry, of A. So first we have cofactor 1 1 of A. Okay, what is it? This is actually the determinant of the minor. Which minor? That this is cofactor 1 1. It means first row gone, first column gone, and we left with negative 1, negative 3, negative 2 and 4. So again here we will have the sign negative 1 and its power is number of the row plus number of the column, meaning plus 1 plus 1. So here we can find it that minus 1 power 1 plus 1 is 2, meaning negative 1 square is positive 1. So 4 times negative 1 is negative 4. Negative 3 times negative 2 is positive 6. What? By the formula it should be negative 6 here. Okay, so this is equal to negative 10. It is our first cofactor. Now similarly we can find the cofactor 1 2 of the A. So now you can see that first of all we can decide about the sign. Negative 1 power 1 plus 2 is 3. So 1 cube is negative. Now what the minor will be? That the first row gone, second column gone. So we left with 2, negative 3, negative 1 and 4. Okay, now we have here negative 1 outside. 4 times 2 is 8, then minus 3 times negative 1 is a positive 3, which is going over here. Now 8 minus 3 is 5. 5 times negative 1 is negative 5. Now let's calculate cofactor 1 3. Cofactor 1 3. So we actually need to find all these 9 cofactors. Now here it is a 1 3, meaning the negative 1 power 1 plus 3, meaning power 4, and we are leaving the first row and third column. So we left with the minor of 2, negative 1, negative 1 and negative 2, and the answer is that is going to be positive 1, because negative 1 power 4 is positive 1, and negative 2 times 2 is negative 4, and then we will have a negative over here. Negative 1 times negative 1 is positive 1, it's over here. Negative 4 and negative 1 is going to be negative 5. Let's continue. We find the cofactor row 2 and column 1. So first row has been done. So now we are going to start our second row. So here again negative 1 power is 2 plus 1 is 3, meaning the negative 1 power 3, so we will get negative sign there. So second row and the first column gone, we left with the 1 negative 2, 1 negative 2 and negative 2 4, negative 2 4. So how we can calculate it? First negative 1 and determinant is 4 times 1 is 4, then negative 2 times negative 2 positive 4, but negative here because of the formula, so answer is going to be 0. So next cofactor is 2 2 2 2 of A. So this means first of all the sign negative 1 power 4, that will turn into positive. Now second row and second column has gone. The minor we left with 1, negative 2, negative 1 and 4. So this answer negative 1 power 4 is positive 1, and 4 times 1 is a 4. Here we have a negative sign. Now negative 2 times -1, answer is positive 2. So it will be over here, and this negative is because of the formula. For -2, answer is 2. Good. So what we are going to do, we are finding cofactors. So rest of the cofactors, I will simply write their answers, because now you know how we can actually find cofactors. So cofactor 2, 3 of A, that is equal to 1, and cofactor of 3, 1 is equal to -5. Now cofactor 3, 2 is equal to, you need to actually calculate these all, that is -1, and cofactor 3, 3 is equal to -3. Okay, good. Now what we do have, we have all cofactors. Okay, so our adjoint, what our adjoint will be, I'm going to write our adjoint over here, adj of a. So we see that we do have the cofactors. For example, 2, 3, that means second row, third column. Okay, but when we are going to write the adjoint, it will be in the transpose form, meaning the row will turn into column and column will turn into the row. So row and columns, they will actually interchange. So our first cofactor was -10. So then second cofactor, that was actually, you can see here, was -5, which was 1, 2, meaning first row, second column. But now we will consider it second row, first column. So you are going to write this -5 over here, and -5, which was actually 1, 3, so third column and first row. But now we are going to change, meaning first column, third row, so -5 will be there, and the next column will be in this way, 0, 2, 1, and third one is going to be -5, -1, and -3. So this is our adjoint. Now we have our value of adjoint and the determinant. We can find very easily the A inverse. A inverse is equal to adjoint of A divided by the determinant of A. Okay, so this is going to be, and our determinant was -5, so we will have here -1 over 5, then times our this adjoint, -5, -5, -5, 0, 2, 1, -5, -1, -3. Okay, that is the A inverse. But we remember that our x is equal to A inverse times C. Now we are going to multiply. So in this multiplication, we have a -1 over 5 times our this -1 over 5. It is actually a scalar multiplication with a matrix, that is actually multiplication with each and every element. We are not going to do this so far, just for simplicity, and then we will do this at the end. First we actually multiply it with the C matrix. So this C is the following: -1.2, 3.6, 15.8. Okay, so this is our multiplication. Now how we can multiply? That we are selecting our first row, and that we will multiply with the first column of the second matrix. Okay, so negative 1.5 will remain here. Let's do this one. Negative 10 times negative 1.2, answer is positive 12. Now plus 0 times 3.6, answer 0. Then negative 5 times positive 15.8, answer will be negative, and that is 79. Okay, now we are going to the second row because first row has finished. There is no any other column, so we have only one column in the second matrix. So we will start with the second row. That will also be the second row of our answer. So negative 5 times negative 1.2, answer will be positive 6. Now plus 2 times 3.6, answer is 7.2. Now negative 1 times 15.8, negative 15.8. Now similarly, negative 5 times negative 1.2, answer is 6. This will be our third row. And then 1 times 3.6, it's a positive 3.6. Negative 3 times positive 15.8, answer will be negative, which is 47.4. Okay, so now let's add them up, and let's see that what our x will be. X is equal to negative 1 over 5, and now our answers are that the 12, and this is negative 79. So answer is negative 67. Okay, now here 13.2, and this is 13.2 and negative 15.8. So answer is our 13.2, and then we have 15.8. Their difference is 6 and 2.6, which will be negative 2.6. And in the same way, this is negative 47.4, and this one is 9.6, and it will be 8, and that will be 7, and that will be 3. So 37.8, what negative 37.8. So all numbers are negative here. Now we are dividing it by 5. This negative sign will also cancel all negative signs, and we know that our X matrix is X, Y, and Z. So this is equal to our this is 67, negative gone, 67 divided by 5, answer is 13.4 positive, and the next 2.6, so this will be positive 0.52, and the third number is positive 7.56. So now this is actually, you can say, the 3 rows 1 column matrix with the comparison of 3 rows 1 column matrix. So from this 1 to 1 comparison, our x is equal to 13.4, and y is equal to 0.52 and z is equal to 7.56. Good. So this is actually the solution of our these three simultaneous equations using a matrix you can say the method. So now what we can do, we can solve the same problem using the Cramer's rule. So in case of the Cramer's rule is very straightforward rule. There are not so many difficulties. It is even simpler. Let's try the Cramer's rule. The Cramer's rule will be in the following way, that for example what we do have, we need to go to the part number 2, solve the simultaneous equations using the Cramer's rule. Okay, what the Cramer's rule is, I explain you in a second. So Cramer's rule. So first we need to note that what actually our A, C and X matrix are, what then that we have actually noted down already in the beginning. So let's remind that what was delta naught. Delta naught was the determinant of A, determinant of our matrix A. So that was equal to -5, if you remember. So then what is the A? A is already given over here in the beginning. Over here I rewrote here. So what we can do, we can take these once again, A and the C. What the A is, A matrix is equal to 1 1 -2 and 2 -1 -3, then -1 -2 and 4. Okay, then the C matrix is equal to our my equal sign is bit away, so let me put over here. Okay, this is -1.2, 3.6 and 15.8. so this is our C. Now the Cramer's rule is a very simple. We can directly even jump on the values of x and y. So the value of x is equal to delta 1 over delta naught. You see, delta naught is the determinant of A. What delta 1 is determinant of A, where first column has been replaced with C matrix, meaning that -1.2, 3.6, 15.8, then rest of the columns will be the same, 1 -1 -2 -2 -3 and 4, and divided by delta naught, which is -5. So this is actually also with the division with all these elements. So now what we can do, we can find the value of the matrix, determinant of this delta 1. That is the same method as we did in the beginning. So I am not writing everything here. I'm simply writing the values of delta 1, which is negative 67. So negative 67 divided by negative 5. So negative gone with the negative, and 67 divided by 5, answer is 13.4. If you actually remember, you see that here we also got, before dividing it by negative 1 over 4, meaning dividing by the determinant of a, our answer was negative 67. So you can also actually compare the values of delta 1, delta 2 and delta 3 with this actually the matrix. Now we go to find the value of y. So y will be equal to, so this is the value of x, and that y value is delta 2 divided by delta naught. That is equal to our determinant of matrix A, where second column has been replaced with matrix C. So it means now this time our first column is 1, 2 and negative 1. The second one will be negative 1.2, 3.6, 15.8, and the third column will be the same, negative 2, negative 3 and 4. Okay, so this matrix we need to find its determinant. That will be the delta 2 divided by again delta naught, which is negative 5. And if you will solve this determinant, you have to actually solve it in the exam, but here I'm writing simply the answer. So negative 2.6 divided by negative 5. So this answer is going to be negative gone with the negative 5, 0.52. So similarly we can find the value of z. So z is equal to delta 3 divided by delta naught. What delta 3 is? The determinant of our matrix A, where third column has been replaced with the matrix C. So here the first column is 1, 2, minus 1. Second column is 1, negative 1 and negative 2. Then the third column is negative 1.2, 3.6 and then 15.8, and we have this determinant delta naught is negative 5. So again I'm just writing here the value, negative 37.8 divided by negative 5, negative gone with the negative, and then you can divide and you will get 7.56. So using both methods, our answer for the x, y and z are similar. So x is 13.4 and y is equal to 0.52 and z is equal to 7.56. I'm sure that you understand this question. So it is very simple and straightforward. So my advice is that go systematically, solve it step by step to gain your maximum marks in your exam. So thank you very much. If you will have any question, you can contact me.